Well-connected and coordinated care across all aspects of a person's health and social needs is key to keeping populations healthy. It is important that health data flows fluently throughout the health ecosystem. For decades, various specifications enabling data exchange between diverse systems used by healthcare providers have emerged. Two modern open specifications, Fast Healthcare Interoperability Resources, or FHIR, and openEHR, have grown consistently over the last decade. FHIR provides a technical framework and a set of flexible data models covering information such as patient demographics, clinical observations, diagnostics, medications, and encounter information. The idea behind these flexible data models is to accommodate a wide range of healthcare data needs. With the growing popularity of FHIR, the number of flexible data model adaptations have exploded. The result is an ever-increasing effort to maintain the exchange infrastructure. When data is being moved between systems using varying implementation guides, there is a risk of misinterpretation that accumulates over time. It's a bit like the telephone game where a message is whispered from person to person in a group. It is likely that the original message becomes altered each time it's passed. Throughout a person's life, they must consider how many technologies, human intermediaries, and governance councils they want handling, translating, and adapting their personal health data. This becomes even more critical when such data is used to train and run artificial intelligence algorithms. The evolution from enterprise systems suggests we should separate data to break free from data silos. Instead, we should aim for a future state platform with an independent data layer that allows everyone to build applications on top of it. Currently, we're on a transitional path to this future state. The flexibility and application of modern web technologies have contributed to the rising popularity of FHIR, facilitating the development of interfaces across various organizations. However, this has led to many different FHIR implementation guides and a multitude of different interfaces to manage. Ultimately, this results in an unsustainable scenario with many varying data models for clinical concepts like body weight, blood pressure, temperature, and many more. So, how can we improve? The answer lies in adopting a system approach that starts with data. We should craft common data models that focus on how clinicians use and store data. If a common data model can be agreed upon, we can then derive the exchange formats, such as FHIR. openEHR offers just this system approach. It has a comprehensive set of maximum information models designed by clinicians and domain specialists. It also has the tools and governance structure to manage the evolution of these data models. openEHR provides mechanisms to adapt these models for specific uses while maintaining universal interoperability. What's more, it offers a robust specification for storing clinical data, allowing for the establishment of a vendor-neutral data layer. This way of working can dramatically reduce the effort and cost to maintain the exchange infrastructure. It can also reduce the risk of translation and interpretation errors. It's challenging to predict what awaits us in the future. With the never-ending evolution of technology and medical treatments, interpreting the future value and significance of health data is a daunting task. To position organizations for the future, standards must be applied based on the specific needs they were designed for. And they can be used for different functionalities when combined. By combining FHIR and openEHR, we can harness the best of both worlds. With openEHR, we can create an open data layer, using FHIR to optimize interoperability. This approach brings us closer to realizing efficient, streamlined, and meaningful exchanges of health data in the future.